Hi, and welcome to Module 3, Azure Service Fabric. Until now, we have learned how clustered computing can help us run containerized applications at scale. Another way to accomplish this is by using Azure Service Fabric. This product also uses clusters of servers to run workloads on. The main difference is that those workloads don't have to be containers only. Let's have a more detailed look at how Azure Service Fabric works. Azure Service Fabric is a distributed platform that allows you to package, deploy, and manage microservices. Service Fabric enables you to run applications on a pool of servers at high density to make optimal use out of the cluster's resources. It comes with a software development kit that enables development teams to create special targeted Service Fabric applications. It also offers a set of tools that enable application deployments and cluster provisioning. You can create Service Fabric clusters in many environments: on Windows, on Linux, on premises, and in the cloud. One machine or multiple servers, it's all possible. In this chapter, we will go through the various options. There are two distinct versions of the Service Fabric binaries. One that runs on Windows and one that runs on Linux. Both are restricted to the 64-bit platform. Service Fabric on Windows can be deployed manually by using a set of PowerShell tools on a prepared group of servers running Windows Server 2012 R2 or 2016. This approach is called Service Fabric Anywhere or a standalone cluster. It's also possible to create a cluster in Azure. You can do this by using the Azure portal or using an ARM template. This will create a cluster and everything that's needed to run applications on it. Finally, there's an option to create a cluster specifically for development use. That runs on just one machine, simulating multiple servers. This is called a local development cluster, and it allows developers to debug their applications before deploying them to a production cluster. It is important to know that for every type of deployment, the actual Service Fabric binaries are exactly the same. This means that an application that works on a development cluster will also work on an on-premises cluster or a cloud-hosted cluster without requiring any modifications to the code. The Linux version is different from the Windows version though, so you can't deploy services that work on a Linux cluster just on a Windows cluster. This is similar to the portability that we discussed on containers. At this time, Service Fabric for Linux is in public preview. This means that not every feature of the Windows version is yet available on Linux, but these will come in future releases. Service Fabric requires you to understand the concept of the application model. Service Fabric applications consist of one or more services that work together to automate a business process. A service is an executable that runs independently of other services and is composed out of code, configuration, and data. Each element is separately versioned and deployable. Creating an application instance requires an application type. This is the template that specifies which services are part of the application. This concept is similar to object-oriented programming. The application type is the class definition, and the application instance is the instance of the object. Multiple application instances can be created from one application type. The same concept applies to services. The service definition and the code, as well as the configuration of the service, define the endpoints of the service used for interaction. Multiple named services instances can be created using a service type. An application specifies how many instances of a service type should be created. Both application types and service types are described through an XML file. Every element in the application model is independently versionable and deployable. While applications run in Service Fabric, they are constantly monitored for health. Service Fabric ensures that the services keep running on all available service resources and that the resources are optimally used. This means that sometimes services are moved from a busy node to a less busy node to keep the overall resource consumption well balanced. Here in the image you can see that we have an imbalanced cluster. Node 2 hosts 3 services, while Node 1 and 5 are empty. Service Fabric will detect this situation and resolve it. After Service Fabric completes the balancing operation, your cluster will look like the following image. Every node now runs one service. In reality, each node will likely run many services. As every service is different, it's usually possible to combine services on one or more nodes and make optimal use of the server's resources. All this is automatically done for you by Service Fabric.